She's got a lot of work history with the Forest Department and the U.S. Forest Service and National Park Service all over the West, including the Great Lakes as well, and the West Coast. So I'm just going to let Toby tell us more about her background if she needs to, and move on. I'm going to turn off the lights over here.
Here we go.
Pictures are much better in the dark.
Okay. And if I want some light for a minute, I can just flip
Yeah.
them on. Okay. So if anybody in the back can't hear me, if I'm forgetting to project, please raise your hand so I'll remember. Thank you for having me. It's a beautiful drive up from Santa Fe at this time of year, and I remember that about a year or two ago, actually, I was driving south from here at this time of year, and they also had a flagman, and I ended up taking pictures of golden cottonwoods and blue skies, and I really appreciated the road closure that day. A little more than I did when I was on my way up today. So I'm going to talk about the Spruce Fir Forest, which is up there somewhere. And at Native Plant Society meetings, at least the ones in Santa Fe, the focus tends to be on wildflowers. And wildflowers are wonderful, and they're beautiful, and they're environmentally important. They make seeds on which you're all experts now, right? But there are a lot of other native plants out there, too. They're maybe not so charismatic. I call wildflowers like charismatic microflora.
Yeah.
So then we've got some plants that are just kind of homely, right? That's actually looks better than it looks where it grows around my house. And, you know, I know that's an orchid, but like even orchids can have bad hair days, right? So, you know, that's just kind of a homely plant. So a lot of times we forget about the full range of native plants that are out there, including trees, the strong, silent type. This just came out last week, very fortunately. I'm sure it was in the Taos news too. So I'm going to talk about trees. Big trees, you know, most of the time we're looking at their midsection and we don't really have an awareness of them. You just kind of walk around and there are all these gray things around you, gray furrowed things and gray scaly things, and the rest of the tree is like either way up there or way down underground somewhere. And these days, when you hear about trees, well, when you hear about forests, what you often hear about, what I often hear about, what we all hear about is fuels, right? We don't talk about trees anymore. We talk about fuels. This forest has too many fuels, or we need to reduce the fuels in the forest. And like, those are trees. And this all came up maybe 15 years ago or so, and the people who were talking about it the most would just say, forests. And now if you pay attention, they tend to say, we need to reduce fuels in western dry forests, or dry western forests. But what everybody hears is forests. And in this part of the country, when we talk about forests and fuels, we're usually talking about our beloved Ponderosa pine forests. So Ponderosa pine trees are very well adapted to frequent fire, and we did suppress fire for a long time, and we had all kinds of grazing that had an effect on the fire regime, and different kinds of logging practices that were historically kind of unfortunate, and they all accumulated to radically alter the Ponderosa pine forest and the dry western forests. So we're trying to reintroduce fire, which I think is why I drove through some smoke on the way here today. And Ponderosa pine loves that. It has very thick bark. It protects the tree from heat, so the cambium right inside the bark, which is what the tree needs to grow, isn't killed by the heat. It has very deep roots. They're protected from the heat. And it loses its lower branches, which is really, really critical. A big old Ponderosa pine, like the type we don't see as often as we should these days, has no lower branches. So fires cannot climb from the surface up to the top of the tree. But not all trees are Ponderosa pine trees. So what I'm going to talk about today is the Spruce Fir Forest. So I teach an introduction to forestry course online, and In the Pacific Northwest, they have big forests that are like pure Douglas fir. There's a chapter of the book that talks about types of forests in the US. It talks about Douglas fir, and immediately afterwards it talks about spruce fir. So all my students think spruce fir is a kind of tree, right? Which, if you use European terminology, it gets very confusing. But in the United States, spruce fir is not a tree, Douglas fir is a tree, spruce fir is a kind of forest that's composed mostly of spruce trees and fir trees. So if you're really into editing, I suppose like one of those is a hyphen and one is an M dash or an N dash or something, but yeah, they're kind of the same to me. So spruce trees and fir trees really love to hang out together. Oh yeah, so just to reiterate, Douglas fir is not a fir tree. Fir is in the genus Abies, Douglas fir is in the genus Pseudotsuga, which actually means like a pseudo-hemlock. For a very long time, nobody knew what a Douglas fir was. It drove the taxonomists crazy. And there are very few trees in the world that are related to the Douglas fir. So it's a Douglas fir. It's not a fir. But firs, true firs, and spruce trees love to hang out together. So in the southeastern United States, we have red spruce and Fraser fir. They're being devastated by invasive insects, but we still have some red spruce and Fraser fir. If you go up to the far north, the eastern Canada, you have black spruce and balsam fir. And here in the Rocky Mountains, we have Engelmann spruce and sub-alpine fir. So the spruce and the fir, they just go together, just like that, spruce and fir. Now, in this part of the country, I can tell by your reaction, a lot of you like know something about forests and know something about plants. I was telling Jan beforehand that Native Plant Society meetings in Santa Fe, we're usually talking to people who know very little about local plants. So you probably know every time you drive up to Taos Ski Valley, you drive through this elevation gradient, or when you go down towards Santa Fe, and the vegetation changes along the way. I have a PhD in ecology, so I'm allowed to make ecologist jokes. There are a lot of people who say ecologists spend their careers quantifying the obvious. And so this is from what was considered a very seminal paper in ecology, where basically the author shows that we have an elevation gradient here. And he collected these data around Taos, and he's looking at moisture going from wettest to driest, from left to right, and elevation going up. So down at the bottom we have PJ, which is like spruce fir, PJ, spruce fir, pinon and juniper, and then pine, ponderosa pine, and then mixed conifer, and then up at the top we have the spruce fir forest. Mixed conifer is just kind of a transition zone, I think, or maybe it's a forest type of its own. And there are not distinct border lines between these. I mean, I know people who think there are, but I don't think there are. And if you walk through the woods, you'll see that they blend into each other. And I will talk about Douglas fir again a little later on, because we often find at the bottom edge of the spruce fir zone, a lot of times you start seeing some Douglas fir that's just inching up into these coldest, wettest areas.
Are those elevations in meters?
Those are definitely in meters, yes, meters. Because academics like to use the metric system.
But the moisture is...
That is an index that
An
he
index,
created,
okay.
yeah. So spruce fir tend to grow they're the very uppermost forest that we have here. They grow in the coldest, wettest places. And when I worked for the Forest Service, part of the time I was the manager for the Pecos Wilderness. People would go into the spruce fir forest and they would see this, and they would always tell me, there's something wrong with your forest. Right? It's got all these dead trees on the ground. There's insects in there. There's diseases in there. Like, why don't you thin it or burn it or something? I mean, I would hear this all the time. And we actually had proposals to thin and burn in the high elevations, which were fortunately killed during the NEPA process. And I always think, well, maybe, these are old growth forests, and I'm going to talk about this a little more later. Maybe if we put moss all over that stuff, like it looks like in Oregon and Washington, people would think it's beautiful. I've actually thought of trying to Photoshop this and cover everything with moss, and then people would say, oh, what a beautiful forest. I mean, if you took all the moss off in Oregon and Washington, this is what it would look like underneath. Our poor benighted spruce fir forests. So I talked about the Ponderosa pine. It's got the thick bark, the deep roots, and it loses its lower branches. And then we have the spruce trees and the fir trees. They have very, very thin bark. On the spruce, it's almost paper thin. So if a fire comes through, even a surface fire, the cambium of the tree is cooked. It's overheated and the tree dies. They have very shallow roots, particularly here where our soils are very shallow in high elevations. So when a fire comes through, the roots are cooked. And they have very, very persistent lower branches, which is why our spruce fir forests look kind of like the haunted forest in Peter Pan with all the branches hanging down, trying to catch you. So the fire can climb very easily into the treetops. Even on the edges of a major fire in these areas where the surface fire has come through, the surface fire kills all the trees. So what you have left is standing dead trees. So I had just walked by here a couple hours before, and this tree was not like this. And then I came back, and it was. And I was kind of glad I wasn't there for the intervening time period, because this is what I call tree shrapnel. If you've ever tried, I tried to pull that one out of the ground, and it's probably got at least 2 feet into the ground. So you can really get, if a tree gets hit like this when you're nearby, you can definitely be killed by flying chunks of tree. And this is why spruce fir forest does not burn very often. This was maybe in July, and the lightning came and it took out this tree in a huge lightning strike, right? And nothing happened. You can't even see a scorch mark anywhere. If this were in the Ponderosa pine, it'd be a very different story. But these forests tend to be cold and wet, and it's hard to make them burn. As a result of that, when trees die, when the wind knocks them down, they accumulate, and they accumulate for very long periods of time. Again, we need to cover all that with moss, right? Then it would be beautiful. The dead and down wood accumulates. The standing dead trees that have been killed by who knows what, a fungus, a bug or something, they accumulate until maybe we have 4 or 5 years of successive drought. 1 year of drought won't do it. 2 years of drought probably won't do it. But if you have year after year after year of drought, then a fire can start in these areas, and you can imagine what the fire will do. Right? It's just going to clean the forest out. And afterwards, you might get these beautiful meadows. And a lot of the meadows that we have up in the mountains here, all through the Sangre de Cristos, are fire-created meadows. The majority of them are fire-created meadows. I always thought I was kind of pretty, but most people didn't agree with me. I don't know. I guess it depends on your perspective. So eventually these trees will fall down. And in a lot of meadows, when you walk around, you see these little pieces of dead wood on the ground. I'm sure you've seen it if you go up hiking. And these pieces of dead wood are from places that used to look like that, or that used to look like that. So what we have is a very, very long, slow process of forests turning into meadows, and meadows turning into forests on a time cycle that is much longer than any of our lifespans. These little pieces of dead wood are very important. It's hard for a little spruce seed to get a foothold in a meadow. But when you have these little pieces of dead wood, it makes a nice little place for a tree to start growing. So I started noticing this with these little trees, and then I started looking more, And you can see down here with a slightly bigger tree. And you can see there with a much bigger tree. And you can see just the end from these trees that are probably a good century old. And then I found a lot of these things, which totally perplexed me when I first saw them. And I asked a lot of people what made them, and nobody could tell me. But I think it's the same all the way around, so it's not like it caught a mudslide coming down. You can walk all the way around the tree, it's exactly the same. And I think this is, again, trees growing on top of an old windthrow or an old piece of wood. Something like, you can see these guys are kind of elevated around the surrounding area. And I think, this is my theory, I can't live long enough to test it, that if you wait long enough, it will look like this. When I found this tree, all the trees on this hillside looked like this. It wasn't unique. This is what they all look like. And you can see it has these lower branches that are very persistent, unlike in the Ponderosa pine. And that's what helps carry the fire up through the trees. And anytime you want to ask me questions, go ahead.
That's obviously fire scorched.
Yes, that is
that a
fire
dead
scorched.
tree?
That is a dead tree.
Okay.
Yes.
Question?
Yes.
What do you believe the downwood is providing for the ceiling?
Well, most likely it's providing climate protection, a little microclimate. Some added moisture,
Insulation.
insulation, yeah. When you're just out there in the meadow as a seed, you're just exposed. But with a little wood, there was research done quite a few decades ago that found that spruce seedlings were very, very sensitive to direct sunlight and overheating. And the overheating actually kills the cambium the same way fire does in the mature trees. So I think that wood just provides a little protection to get it started. So you can get these meadows, like I showed previously, after a fire. In wetter areas, you can get these beautiful, lush explosions of berries and wildflowers and all kinds of things. This is closer to a creek. And I think you don't really notice that the trees are dead. I mean, it's just so beautifully lush and flowery, or maybe I've been looking at dead trees for too long. Another possible aftermath of these fires is aspen. And of course, you can get the big aspen groves that come up from those clones that have been just waiting underground for a couple hundred years for their opportunity. Or in some places, we get big moss beds. And I believe these aspen are coming in from seed. And they find, again, a nice sheltered, protected environment in a bed of moss. So over time, that burned up forest will grow into a new forest. Nature's relatively even-aged forests. You know, often we hear that even age is kind of a bad term, but after you have a fire like this that kills all the trees, the forest that comes in initially is pretty even-aged. And at first, it's fairly open, the light can come down through the canopy, and you can get quite a bit of undergrowth in the forest. But as time goes by, the canopy will close, it will get darker and darker, and you won't have much vegetation left on the forest floor. And I went through my pictures, I didn't have any pictures of dark forests with bare floors, so I don't have one of those to show you. But if you go hiking, you can certainly find them in the closed forest where very little light gets to the ground. You know, there's a lot of needles down there, and there's trees that are struggling to grow, but you don't find much other vegetation.
Do the lower branches, the needles die off before the canopy closes?
They seem to be doing that here, and as you're suggesting, the needles die off because lower down on the tree they're not getting enough sunlight. so they die because they're shaded. That tree right there, you know, I think, this is all lichen on that tree. I think that tree is dead. And over here, down here, they still have some needles, so yeah, I think this one just didn't make it. So over time, the forest canopy will close, but then what happens if you wait longer, maybe another 250 years, these trees will get fungal diseases, they'll get a few beetles, they'll get some spruce budworm, and actually the forest starts to open up again on its own. And then you start getting more undergrowth again, and then people come into the Forest Service office and complain because there isn't any moss growing on this. Right?
Toby, where's this picture from?
These pictures are,
Is it Pickle?
most of these pictures have been Pecos, but I think this is a picture from a couple years ago. I went over to San Pedro Parks and had been really hammered by the spruce beetle.
Oh,
And I think this is from the spruce beetle in San Pedro Parks.
they just look really tall, those spruces.
Yeah.
Excuse me, but do the diseases develop when the forests become overcrowded? And that was a way for them to thin out?
Well, I guess I wouldn't attribute a purpose of thinning the forest. Over time, and I wouldn't say the forest is overcrowded either, because I don't like to make judgments about the natural sequence of events in the forest, and that makes it sound like there's something wrong with it, unless we put moss all over it. So, as the trees get older, they become more likely to develop disease problems or insect problems, just like we do, right? And I don't know that we can put a finger on why that happens. It does happen, but I don't think, you know, there are a lot of, we don't know how trees die, and we don't know why trees die. There was a researcher at Los Alamos who was doing some research on that, and there are people doing it in other places as well. But in fact, we have a very hard time telling when a tree is dead. I mean, not like these are dead. But, you know, the tree is there, it has green needles, and then one day they all turn red. But when did it die? So we don't know when a tree is dead, and we don't know the process by which a tree dies. We can say maybe it's not photosynthesize, you know, if it loses all its needles, maybe it can't photosynthesize anymore and it might die. Or if the cambium is all filled up with a fungus and the water can't get from the roots to the top, that can kill it. But those are very obvious things. All these in-between things, we don't really know how trees die. So how's that for not an answer? So you should do a research project. Yes?
Are you aware of chemtrails?
Of what?
Chemtrails.
Yes, I am aware of chemtrails.
So would they not affect the health of the forest?
Well, let's hold on to that thought until I get to spruce beetles.
Okay.
Okay. I lost my train of thought here. Oh, and that's because I went backwards. Okay, so once the forest opens up again, we start seeing, ta-da, our beloved charismatic microflora. The raison d'etre originally of a lot of native plant societies. There we go. Or these guys. Don't ask me what species that is.
That's it, Jen.
It is a gentian. Yeah, it's a gentian. It's a little bit blurry, but I like it anyway. So what we have here, the big picture of what I'm talking about, is we have a forest that moves in very long, slow cycles. The trees initially reach their maximum seed production when they're about 150 years old. And at 250 years, they'll still be producing big seed crops. So if we go in, for instance, and try a surface fire and kill them all when they're 100 years old, because we cooked the roots or the cambium, they won't even have produced seeds yet. So this is, it's just a different way of looking at a forest. And when they're 300 years old, they can be happily growing away. So these forests are what I call our very underappreciated, misunderstood old growth forests. They are old growth forests. And they just don't get kind of the acknowledgement that they deserve. So it's a very slow cycling forest. The combination of cold and wet means that fires are infrequent, even though there is plenty of wood or fuel to burn. And there are other processes in there that affect the forest, such as occasional outbreaks of bark beetles or spruce budworms, which we're having a lot of right now near Santa Fe. I don't know if you are here or not. So, bugs, right? We all got traumatized by the pinyon juniper mortality, which was like 15 years ago now, so it's time to get over it. Trees have a lot of bugs. I didn't bring my statistics, but people have done experiments where they count the total number of bugs in one tree canopy, or the total number of species of bugs in one tree canopy. Unfortunately, they usually do this by fumigating the tree canopy and then seeing what drops out. Sometimes they just do it by shaking it a whole lot. You can beat the leaves the way you do to see what's eating your apple tree, see what falls out. But you can find thousands and thousands of bugs in a tree canopy at any one point in time. They're eating the leaves, they're eating the lichen, they're eating the fungus, they're eating each other, because some of them are predatory insects. And tree canopies are full of insects. These insects have been eating trees for a really long time because, I'm a guest speaker. I'm going to make a political remark. And if you don't like it, you can boo and hiss. Okay, so regardless of what the no longer proposed New Mexico science curriculum said, the bugs and the trees have both been around for a lot longer than we have. So there have been bark beetles for, oops. Oh, wrong way. There have been bark beetles for between 100 and 145 million years. These are the names of the titles of two papers that have just come out in the past 5 years or so. I didn't put in the full citation because I'm just using the names as an example. Right? 100 million years of morphological conservation in bark beetles. We're the most ancient bark beetle known. There's a paper with this title that comes out about every 5 years, the most ancient bark beetle known. And because they find them in amber. Conifer trees make amber, and amber catches insects and preserves them forever. So if you keep looking at amber from conifer trees, you can find lots of interesting fossilized insects. So the bark beetles and the trees have been having what we call an evolutionary arms race for 100 to 145 million years, where the tree develops another defense, the bark beetle develops another way to try to get the tree develops another defense, the bark beetle tries to find another way to get into the tree, and they are where they are today. And what we have to remember is that trees are plants, and people tend to freak out a little bit when trees get bugs. But we all know that plants are at the base of the food web, right? There's a plant, bug eats the plant, lizard eats the bug, the bird eats the lizard, right? The bobcat eats the bird. And we recognize that when we see deer grazing on grass. But we don't recognize it when we see caterpillars eating the leaves of our trees. Trees are giant, overgrown plants. That's all they are. So as big as they are at the base of the food web. And there's a whole ecosystem in forests that depends on the trees being at the base of the food web. So, let's see, this one goes this way. This one is a predator. I talked about the bugs eating bugs. So this is a bug from, I don't know, 100 million years ago or so, that was a predator of bark beetles. And this is why I said to your chemtrail question, let me get to the bark beetles, because the trees and the budworms and the bugs have been engaged in this give and take for 100 million years, or 150 million years, or 75 million years, or however long it is. And this was happening long before we ever affected the forests. The bark beetles could wipe out a forest, the trees could come back, a fire, yes.
What do you mean by chemtrail?
Let's not
You
go
want me to
there.
tell him?
Let's not go there.
Well, I'll just say,
agree.
I'll say briefly that some people are concerned by the chemicals that come out of jet exhaust and have concerns about its environmental effects.
I know what that is.
Okay.
Thank you.
So, although people are undoubtedly having an effect on the environment, these basic issues, and this is how I always start my online forestry course, is that trees got bark beetles 100 million years ago and we still have trees today. You know, trees, you can go look at the petrified wood at Bistig Badlands, and there are places where it obviously, like it looks like a campfire. I mean, it's like fossilized, charred wood. So trees and fires, trees and bugs, trees and fungi, they've all been interacting with each other for a very long time, and it wasn't always positive for the trees in the short run, but in the long run, they've all made it to the current era. So I've been talking about the forest, and now I'm going to talk a little more about the trees. These two specifically, the Engelmann spruce and the sub-alpine fir. So this is the distribution of sub-alpine fir. I didn't make this map. If anybody here is red-green color blind, I apologize, because I think that's going to be all gray. But basically it goes from the border of Canada and Alaska straight down through the Rocky Mountains and kind of trickles out in Arizona and New Mexico in our high places. So subalpine fir tend not to be very, very long-lived trees. They tend to get fungal diseases, particularly heart rots. I just walked by this tree on Saturday. It's like, oh, I can make a heart rot slide. So this tree had heart rot, and here's the rest of the tree. It's at a funny angle because it had fallen across a trail, and the trail crew had cut it and pulled it to the side. But this is classic heart rot. Heart rot is a fungal disease. The fungus eats the tree from the inside out. When you see, tree ears and fungi and things sticking out of trees, that always means there's something eating the tree from the inside out, and it's decided it's time to reproduce, and it pushes its way out through the bark with the fruiting body, which I always equate to something like alien, right? So the fungus is in there. When it's ready to reproduce, it pushes the fruiting body out through the bark. One thing that subalpine fir trees are very, very good at is living in the understory for incredibly long periods of time, waiting until something near them dies so they can get sunlight. So the question is, how old is this tree? And subalpine fir trees can do this remarkably well. So this is a tree core from a subalpine fir tree. And from here to here,
Do we need the light on?
can you see this?
Yeah.
upper one.
Upper one.
Oh,
Okay.
the one that says
Yeah,
lights?
That's just a little
Like
light.
the other room.
Okay.
There you go.
So this is a core from a sub-alpine fir tree, and from here to here is 270 years.
Finger to finger.
Finger to finger, because this is going out the other side of the tree. Finger to finger is 270 years. So this is maybe a 5 or 6 inch diameter tree, and it's 270 years old. Most tree species cannot do this. Where am I going?
Do you want to leave the lights on?
Yeah, if the slides look okay, and then if one is too washed out, I'll turn them off again. This tree is, see how it's bringing its branches out as far as it can? And I had a better picture with one that had really long needles. But what it's trying to do is catch every little bit of sun that it can down there on the forest floor. And they tend to get very, very long needles because they're just trying to catch the sun. I don't know how old this one is, but it could be a very old tree. Now, occasionally sub-alpine fir do spectacularly well. This is a very unusual one, but it does happen. This is on the Coconino National Forest, and it is a 65-inch diameter sub-alpine fir tree. I've never seen one that big, personally. It's considered a champion tree, if you're into champion trees. But it's really a remarkable tree. There's a little man down there. But he's really not little. He's a normal-sized person. So it's just a very big tree.
Where's it growing?
Somewhere in the Coconino National Forest, but I don't know where.
Up on the Mario Rim, up high?
You know, I don't know. If you go to the American Forests website and look for sub-alpine fir, well, it calls it a cork bark fir. It might tell you the location. I don't know if they do or they don't. So cork bark fir is a local variety of sub-alpine fir that I forgot to mention. For a while, it was considered a different species. It's no longer considered a different species. It's just considered a variety. And it's a sub-alpine fir that has very quirky, they call it corky bark. I find it kind of spongy, but it's bark that has kind of a peculiar texture to it. Yes?
The circle of white.
I think that was like a something on their lens.
No, it's a spirit board.
Okay. With the tree.
So,
Yes.
I just was going to say that's probably closer to the Vosgian Rim. It's more of a Ponderosa pine savanna with some Gary oak and the understory. Then as you move toward the San Francisco peaks and you get the cold air drainage, you get these pockets where the spruce fir come down, and this I think is in one of those areas, but I can't be sure which one.
Are you thinking like Sycamore Canyon or places like that?
No, if
Oh.
you get down in the canyon floor, then you're
Yeah.
getting that riparian forest, but you have to be actually up kind of above the
Yeah,
rim
yeah.
toward like near Flagstaff,
Yeah.
kind of going up into the San Franciscos for this. But there's some places like in Hopi where Keams Canyon comes down, where you
Yeah.
go up and you see these trees just, and it's in their tradition, they know these trees. So they do occupy these microsites in places you don't expect.
Yeah, microclimate is very, very important. And that's why you often find, Doug-fir out in the middle of the desert. You go into some canyon and there's Doug-fir in there.
Echo amphitheater.
Yeah,
Yeah.
yeah. Douglas-fir.
Yep.
Wait, wait.
At the computer, yeah.
Okay, so a fir tree has vertical cones on its upper branches. It does not have cones that fall on the forest floor. Over time, as these cones mature, the outer scales will fall off and they'll just be like a spike sticking up on the top of the tree. So when you're trying to figure out, like when we're kids, most of us, I know I did, if it's like evergreen, it has needles, they're all pine trees. And then when you get older, you realize, they're not all pine trees. And then you have to figure out which ones are which. So if you see a cone hanging off of a tree branch, it is not a fir tree. If you want to see these without straining your neck, the best way to do it is to hike or drive up a steep road and look down on the treetops below you. That is my favorite way to find fir cones. So this is the range of Engelmann spruce, and you can see how remarkably similar they are. I didn't check, to see why the fir doesn't like it here and spruce does, but they're really remarkably similar. Out here on the coast, there isn't any Engelmann spruce because there's Sitka spruce up here. And the spruces tend not to overlap. So, I did a research project on a fire after it burned. That's why I have lots of pictures of burned forest. This again is underappreciated old-growth forest. So when I sampled this plot and cored trees in it, every tree that I cored, which was only the larger ones, which would be like this gargantuan tree right here, or this massive tree right there, every single one of them was over 300 years old. Now these trees are, we're up here in Taos, but if you're in the Pecos wilderness on the far east side of the wilderness, you can be up on a ridge line there that kind of goes north from Hermit's Peak toward the Santa Barbara Divide. And these trees are on that ridge line. So some of the trees I cored up there, I couldn't tell exactly how old they were because you lose a lot of cores below where you core the tree, and the trees were growing so slowly at the innermost rings that I assumed they'd been growing tremendously slowly before then too. So I couldn't really estimate how old they were. But I believe these trees, and you could look out over the plains from these trees, were there when Coronado went by, which was just kind of literally went by because you could see Las Vegas from there, which was really kind of a mind-boggling thought. So I don't have the oldest core here, but this one, the center of the tree is here, and the outer edge is here. So this is 360 years. And so this is one of the things I wanted the easel for, actually, now that I think of it. So if we, if I were just to rotate this around, let's see if I can hold that center point steady. I think I moved it. Kind of hard to do when it's not at the end. Oops. Well, we'll call it a rough estimate. Anyway, if you were to draw a circle here, it's not very circular, that's the size of the trees up there that were mostly, like between 300, my guess would be 350 to 450 years old. But you can tell, if somebody went up there before it burned, you couldn't even walk through that, right? All the branches are tearing at your clothing. You can't get your horse through there. You can't get your cows through there. And, it's not very people-friendly forest. So another interesting thing that Engelmann spruce do and sub-alpine fir, I've read they do it, but I haven't witnessed it as much as I have in Engelmann spruce, is they will reproduce by layering. So after a fire, if a tree gets a start in a meadow, an open grown, now that I have this, I can't draw to save my life, so this is really dangerous. a tree that grows out in the open, where it's sun everywhere, it's growing in the middle of the meadow, tends to be a large diameter tree. There are only a few places in the United States, and I've actually done graphs on this, and there's a published one in a paper I wrote. There's very few places where there's any kind of a strong relationship between the age of the tree and the size of a tree. So trees that grow out in the open tend to be very big, very wide, and have big bushy crowns. You know, they're branches. But trees that don't get so much sun, including trees that grow on north-facing slopes, tend to be much taller and thinner at the same age, and all their needles or leaves or whatever they have are up here because they're trying to get the sunlight. So an open-grown tree has these big branches, sweeping branches, that come out near the ground, and we know that spruce trees don't lose their branches. And what they will do is root and make new trees. So you can see these are all coming out like the spokes of a wheel. The center tree, the mother tree, was the oldest one. I don't know if it was alive before the fire or not. So the center tree died. And most places I found that looked like this, these connections before the fire had been totally covered by the duff. So what you would have seen was a tree with kind of a circle of trees around it. And what you would think is, well, you know, like the apple doesn't fall far from the tree, right? The spruce seeds hit the ground and a new tree germinated. But what you're actually seeing is that these are all connected. This is like mama tree and all the baby trees around it. Another characteristic of spruce trees, to help you figure out what you're looking at, is that when you pull a needle off of a spruce twig, it leaves these little pegs. Bark-wise, spruce have scaly bark, often with reddish scales. That one's really gray, but often they're kind of red. And sub-alpine fir has this kind of smooth bark. Sometimes I find it looks kind of strange. That's the best way I can describe it, is strange. It can be spongy, it can be corky, but it doesn't look like that. And if you're trying to figure out, well, what if I'm looking at a Douglas-fir? They have really thick, gray, furrowed, ridgy bark. Like, think of like an old oak tree or something. So here we can do a little comparison: reddish, scaly bark, smooth gray bark. A lot of sub-alpine fir trees get what are called resin blisters, and they're places where resin is just kind of bulging out of the tree. So you'll see this amber-colored ooze on the tree, like when your peach tree gets a disease. And that's just a characteristic of sub-alpine fir trees. There's nothing wrong with the tree. Spruce have sharper needles. Sub-alpine fir has softer, blunter needles. I was going to demonstrate with my needles here, but they got mixed up, and I'm not 100% confident which is which. And I should be, but there's something that, yeah. But anyway, you wouldn't want to shake hands with a spruce tree. Shake hands with a spruce tree, it'll poke you, and you can shake hands with a fir tree. Spruce trees have cones on the ground below the tree. Fir trees do not, because they have those funny cones that stick straight up in the air. And on a fir tree, the needles leave those pegs on on a spruce tree. And on a fir tree, they don't. So when you do see two kinds of cones on the ground, most often you've run into an area where there's some Douglas fir mixed in with the spruce trees, and you're seeing Douglas fir cones. So this is a spruce, and this is a Douglas-fir. Douglas-fir have spiky things on their cones. You don't want to shake hands with them either. This doesn't help you when I walk back and forth, does it? Okay, I forgot. So if you're unfamiliar with them, I brought some show and tell, which was always the best part of first grade. And you can pick these up if you want afterwards. This is a spiky Douglas-fir cone. And this is a nice, smooth Engelmann spruce cone. Yes?
What we say is that the bracts look like the mouse, the hind feet and the tail of the mouse that's gone in to get the seed.
Yeah? Some people say that, did you hear that? That these bracts look a little bit like a mouse has gone in to get the seed, and so these would be his hind 2 feet here, and then that's his tail. It does look like that. Some people say it looks like a trident. You can come up and look at them afterwards if you'd like. And I mentioned there's a whole ecosystem in these forests that's dependent on the forest. So if you hike or picnic or anything in the spruce fir, you've met the spruce squirrel. It's the one that sits up in the trees and chatters its head off at you. And spruce squirrels are, they're the denizens of the spruce forest. Each one has a very, very protected territory. They're extremely territorial animals. They might have 1 tree that's theirs or 2 trees that are theirs. They collect spruce cones, and I guess it's a day-length thing. There's a time in August when they just start collecting spruce cones. And if you walk around in the forest, you will be pelted with spruce cones. So I was doing a research project, and I was camped in the Pecos Wilderness for a very long time. I had a tent back in a grove, for protection from monsoons. And one August morning, it's like first light, and the roof of my tent is going like bang, 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 bang. So every morning until I packed up and left in the middle of September, as soon as the first light hit the trees, my tent would go bang, 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 bang. So that's spruce squirrels collecting all their cones. For the winter, they cache them in the ground, and you may have seen these big piles of spruce cones or the scales from the cones or the old dead cones on the ground, and those are the middens, and that's where the spruce squirrels store their food for the winter. Now, while they're very busy collecting the food that's in the top of the trees and taking it down to the ground, they're also collecting the food that's on the ground and taking it into the trees. So spruce squirrels have this very interesting habit of they run around and they harvest mushrooms. And then they store the mushrooms up in the tree branches. And the first time I saw a spruce squirrel do that, I thought, well, this is a very strange spruce squirrel. And then I found more, and then when I looked around, I discovered if you spend a lot of time walking off trail and looking at the tree branches, in the late summer, early fall, you can find like these mushrooms in the tree branches. And then if you go and look in a wildlife book, it will say, other people have discovered this before I did, it will say that this is a known behavior of the spruce squirrel. So what I've tried to do is create a picture of a forest that's a very different kind of forest than a Ponderosa pine forest. It's the whole paradigm that we hear nowadays of frequent surface fire, wide open park-like forests is not applicable to this type of forest. It's totally appropriate for Ponderosa pine forests. It might be totally appropriate for the lower part of the mixed conifer forest because these are all gradients, they're not strict lines. But once you get into wetter forests, fire was not a frequent thing because fire is simply a physical process. It doesn't care what kind of tree is there. If it's wet, it doesn't burn. And if it's very cold, it's much less likely to burn. So cold, wet places just don't have a history of fire, and the trees never had to develop any adaptations to fire. It's the same way if you go to the other end of the spectrum. Places that are very hot, don't burn very often because they're so dry that there isn't anything to burn. Right? They don't have a lot of fires in Death Valley. And these two ends of the spectrum, they come closer and closer together, and there's kind of a sweet spot in the middle where you have enough rain that you get a fair amount of vegetation growing, but not so much rain that it will not burn. And it's not so hot that nothing grows, and it's not so cold that nothing grows. And so that area, anywhere you are in the world, is where you get your frequent fire ecosystems. So that's kind of a big picture way to look. I mean, you can refine that in little ways, but in a big picture, that's a good way to look at it. So this is, I think the end of August, beginning of September. Nice monsoon, ground was covered with hail. That's hail. And I think the following week my gloves froze overnight. And so this brings me to the elephant in the room that I haven't been talking about, right? So what's the elephant in the room?
Climate change.
Yeah, climate change. So I've been talking about the way these forests are. But I don't know how these forests will be. And what I do know is that you don't see this kind of weather as often as you used to in the summer. There aren't as many below freezing days in the high elevations in July and August as there used to be, or in June and September as there used to be, or where are we now, October? How many times has it frozen this year? It's October. So a forest is a very interesting phenomenon because everybody here is into plants, and like, how many of you garden from seed? Yeah, a lot of people garden from seed. When is a plant at its most vulnerable?
As a seedling.
When it's a seedling. So a forest, any forest, is an indication of what the perfect growing conditions were for seedlings in whatever era those trees germinated. So these forests, 200, 300, 400, 500 years old, however old they are a reflection of good germination conditions that occurred 300 or 400 years ago. Do we have good germination conditions today? I don't know. Maybe we do, maybe we don't, maybe we do in a smaller area. So the question is, what is going to happen? Right? That's the million-dollar question. And there's a fair amount of, about once a year, there's an article in at least the New Mexican about research that's done locally that typically makes a big pronouncement. I think the last one came out a few years ago. It said, there will be no trees in Santa Fe County by, I think the year was 2050, but it might be 2090. So, and that came from, well, somebody I know who researches these things. The information that we get, we don't have that many big academic institutions around us. So the information that we get tends to be from a small group of people who work very closely together and use very similar methods. And there is a global community of people who are working on these issues, thousands of people, using lots and lots of different methods, many different methods, coming at it from different angles and from different perspectives. And so when we see a pronouncement that says, there will be no more Ponderosa pine forests, because I've seen that one too, or there will be no trees in Santa Fe County, and it comes from one person, what you really want to do, I know you want to do this, you want to do like a literature review of the subject. and see what everybody else is saying. And see what information you can get from people who are employing different methods and different perspectives. And the fact is that if we say what is going to happen to these forests, nobody knows. We really do not know, because natural ecosystems, my husband comes out of a physical science background, and I know there's some people in this room who can relate to that. And every piece of research he ever did in his career, starting when he was an undergraduate, the data were collected by a machine. He never hand collected a single piece of data in his life. Okay, and then he went out to help me in the field. And it's a good thing we'd already been married for a long time. It was a disaster. And then I said, you're an internationally known scientist. Like, why can't you measure a tree for me? And he said, well, I've never had to actually collect the data before, and it's so imprecise. It is so imprecise. Now, I see some knowing smiles out here. The natural sciences, the biological sciences, the ones, not the biological sciences in the petri dish, but the ones that are outgrowing, are incredibly complex systems. And if you simplify them the way we like to do for many other kinds of things, you get answers that might be excluding an extremely important factor because we don't know what all the important factors are. So the climate is going to change. Most of us agree on that. The climate is changing. Most of us agree on that. And we know that globally, average temperatures are increasing currently. So what does that mean for the temperature in this location? What does it mean for the average nighttime temperature, the daytime temperature, the winter temperature, the summer temperature? Is precipitation going to be the same but distributed differently throughout the year? Is it going to be more? Is it going to be less at this precise location? Is it going to be more rain, more snow? Is it going to be raining in January? And if it is raining in January, will we get Sitka spruce instead of Engelmann spruce? So there are all kinds of fungi in this system. There are birds that transport seeds. There are rodents that transport seeds. There are interactions among the species. And nowadays, we don't have a method of incorporating all those things into a model and coming up with an answer that we can downscale to a single place on a map. So we can make very big generalizations, but what's going to happen to the Pecos Wilderness? What's going to happen in Latier Peaks? What's going to happen on Wheeler Peak? We can make some guesses, but we don't know. And that's the best I can do at this point, as well as to say, when you hear people make pronouncements, you don't necessarily have to ask them questions, but ask a lot of questions in your mind. Ask yourself, what did they factor in here? What kind of method did they use? Does that make sense with what I see on the ground? Does it make sense with, if I compare this place to someplace in Arizona or someplace in southern Colorado, does it make sense? Because a lot of times, it doesn't really make sense. I mean, it sounds good, it doesn't make sense. But sometimes it makes sense. And I think for the most part, it's going to be a wait and see game, and it is going to happen, but we don't know what it is. And my final thought on that is that's particularly difficult to predict in this part of the country where we have such extreme topography, which means almost everything is a microclimate. You're on a south-facing slope, you're on a north-facing slope, an east-facing slope, a west-facing slope. You're in a place that gets cold air drainage at night. You're in a place that gets huge upwellings of hot winds during the day, which is true up near Pyramid Peak. There's this enormous draft of hot air that comes up there all the time. It's really extraordinary. It's coming up from the plains down below. So in areas that are flat, like Nebraska or like Kansas, it's probably easier to say this might happen to this particular species or that might happen to this particular species. But with our topography, what happens on a north-facing slope might be very different than what happens on a south-facing slope. Yes?
Actually, Jody, I was going to suggest that you just, maybe if you have an example where you could describe the tree rings on one trunk and how the north-facing and the south-facing can be completely different in the same growing season.
Right, so on a tree ring, the rings aren't always circular.
But especially for these guys, right? And
Yeah. These, well, I'll save that thought, because it's kind of a tangent. It's not a tirade, it's a tangent. So I think that is, where I was going to end, and I'd be happy to take any questions.
Is that early morning fog or is that smoke?
That is fog. The smoke had been 2 years earlier.
Okay.
That was a miserably cold, horrible day in August. It was just above freezing. I couldn't find the plots I was looking for. It's probably one of the worst days I had in my entire field season, and it produced a beautiful picture.
Good.
Thank you. Whatever the truth is.